In homework number 8, there's quite a few questions having to do with vectors. This video um, is going to attempt to explain what exactly a vector is and how you combine vectors. There's two formats that we are typically given a vector in and that we can work with vectors in. Most of the time, application problems will refer to vectors as a magnitude and a direction. And that's really the definition of what a vector is. It's a value that also has a direction associated with it. Oops, sorry. So anytime you think about an application problem where you're given a number, most of those are just scalars. They're just numbers. But there are other types of numbers where it would make sense to also attach a direction to the number. So when you're driving and you talk about the velocity of your car, a synonym for that would be speed, but mathematically and in physics there's a difference between the two. But velocity technically is how fast you're going and what direction you're going. So if you wanted to describe to somebody your velocity, you could say that you are traveling at 20 miles per hour in a direction northeast. So it's a value and it's a direction. So all a vector is a value that also has a direction associated with it. In most application problems, they tell you the magnitude or the value and the direction. The problem with that, though, is we can't do calculations usually with a magnitude and a direction. What we need to do is we need to change it to components in order to do calculations. So the applications refer to vectors one way, but for calculations, we need to think of vectors as components. We need to think of them as a horizontal component and a vertical component. And the reason we need to do this is we can only add, if you think about it back from basic algebra, we can only add like terms. So if we break a vector down into how much left and right does it have and how much up and down does it have, we can combine up and down pieces because they're like terms, and I use that loosely. And we can add left and right pieces because they are like terms. All the left and right movement is along the x-axis. All the up and down movement is along the y-axis. So you can only combine vectors, or you can only combine vectors that are pointing in the same direction. So I can't combine a vector that's pointing northwest with a vector that's pointing east, because they're two completely different directions. But if I break them down into components, I can combine their components, because all components are horizontal and vertical. And I'm going to show you a little diagram of how all of this stuff works together. And all it is a right triangle. So we can graph, or we can visualize a vector with a directed line segment. So we might call this vector V. And the little arrow on top of the V is just the symbol that we use to let people know that this is a vector. The length of the vector represents its magnitude. So a longer line segment there would mean a larger magnitude. A shorter line segment would mean a smaller magnitude. And then this angle right here is the direction. So in this right triangle, the hypotenuse is the magnitude. That's our vector. And then that angle is the direction. And what we want to do so that we can do calculations with this vector is we want to break it up into how much horizontal movement is inside of it and how much vertical movement is inside of it. And that is exactly what these two legs are. And we call that V sub x because it matches up with the x-axis, which is horizontal, and V sub y because it's vertical, matches up with the y-axis. Those are our components. So usually with magnitude, we put bars around the vector. So this is the magnitude of V, vector V, and theta is the direction of vector V. So that's one way to represent a vector as its magnitude and direction. And on a right triangle, that's just the hypotenuse and the angle. Another way to represent a vector is with the legs of the triangle, which are the V sub x and the V sub y. And this is the horizontal component. And the vertical component. So since all of this stuff is just related with that right triangle, we just have some very simple triangle and trigonometry formulas to help us switch back and forth between our magnitude and direction format for representing a vector and our component format for representing a vector. So typically, when we're given a problem, we're going to be given the magnitude and the direction for the vector, and we'll be asked to do some calculations. The very first thing we need to do is we need to change our vectors to components. We can't do any calculations from magnitude and direction format. All of our vectors have got to be in component form. So the first thing we do is we change our vectors to components. Once our vectors are in component form, then we can combine corresponding components. So I can combine all of my x components from my different vectors, and I can combine all of my y components from my different vectors. Because all of the x components are horizontal, so they're all pointing in the same direction. All of my y components are vertical, so they're all pointing in the same direction. This will give us the components for our answer. But if the question was given in magnitude and direction format, most likely they're going to want the answer written in magnitude and direction format. So once we get the components for the answer, we're then going to switch those components back to magnitude and direction format. So convert back to magnitude and direction format to state final answer. So we have to change our vectors to components in order to do the calculations, but then we want to convert it back to magnitude and direction in order to state our final answer. So we need some conversion formulas because we've got to convert two components and then we need to convert back. So if you look at this triangle again, to start the problem, we're going to know magnitude and direction. We're going to know the hypotenuse and we're going to know one of the angles. And we're going to want to solve for those legs. So if we know the hypotenuse and we know the angle, and I want to solve for the adjacent side, we're going to think of a trigonometric function that uses adjacent, hypotenuse, and that angle. And the trig function that uses adjacent, hypotenuse, and that angle is cosine. So we can set up the cosine equation, and I'm going to do that in a second. And then for y, the y component is the opposite side. So to solve for the y component, we're going to set up the sine equation. So if I set these equations up, the cosine of theta is the adjacent side over the magnitude. And we're trying to solve for v sub x. So we're going to want to multiply the magnitude over. So v sub x is your magnitude times cosine theta. And then that exact same triangle, sine is your opposite side, which is the y component, over your hypotenuse, which is magnitude. And we're using this formula to try to figure out the y component. So if I solve that equation for v sub y, I'm going to want to multiply magnitude over. V sub y is the magnitude of v over sine theta. These are the conversion formulas to change from magnitude and direction to components. So this is when we know magnitude and direction. There's our magnitude and direction. So this is when we know them and we want to find components. So this is step number one. We're taking magnitude and direction and turning them into components. Once we know the components, we would just combine all the x components and combine all the y components. And that's going to give us a final answer in component form. Once we know a final answer in component form, we're going to have to convert it back. So the final answer to a vector problem is called a resultant. So it's typical for you to see the capital letter R used for the final answer. R for resultant. So once we convert to components and then we combine the like components, we will have components for the answer. We'll have r sub x and r sub y. And we want to take these and turn them back into a magnitude and a direction. So I'm going to scroll back up to my triangle so that we can see again what pieces we have and what we need to do to turn them back into magnitude and direction. So we have components. We have an X, we have an X, and we have a Y. But we want a magnitude. So for that one, we've got two sides of a right triangle. We've got the two legs, and we want the hypotenuse. So to figure out magnitude, we've just got to do the Pythagorean theorem. So the magnitude of our answer, the magnitude is just the square root of r sub x squared plus the square root of r sub y squared. That's just the Pythagorean theorem solving for the hypotenuse. To figure out theta, which is our direction, figure out this piece. And remember, we know v sub y and we know r sub y, we know r sub x. And we're trying to figure out theta. Well, based on where I've got theta, we know opposite and we know adjacent. So we're going to set up a trig function that uses opposite and adjacent, and that is the tangent function. So for theta, tangent of theta is the opposite over the adjacent. And to solve for theta, we would move the tan to the other side as a tan inverse. You need to be really careful when you do this, because tan inverse in your calculator does not always give the correct answer. Sometimes it only gives you a reference angle, and you need to move that angle to the correct quadrant. So you need to be really careful with what quadrant your answer needs to be in and what quadrant the calculator is giving you. Now you can tell what quadrant you should be in if you think of your components as a point. So this is the set of formulas we would use to convert components back to magnitude and direction. So if I did this calculation and I got a negative x component and a positive y component, think of those as coordinates on your graph. A negative x and a positive y is in quadrant 2. So I would have to make sure that when I gave my final answer for theta, that my final answer is a quadrant 2 angle. Your calculator will never give you back a quadrant 2 angle for tan inverse. Your calculator only uses quadrant 1 and quadrant 4 for tan inverse. So you would have to think of that answer as a reference angle, and you would have to move it into quadrant 2 on your own. So there's a couple of homework problems I'm going to go through real quick here. And the first one is, let me see what actual number it is. It's question number 4 in the homework. Question number 4 in the homework. They give you the magnitude for two vectors, and they give you the angle between them. It says the angle between them is 45. Now, normally, each vector would have its own angle, and because they didn't give you an angle for each one individually, we can just assume that one of the angles is 0. So I'm going to say that U's angle is 0, and V's angle is 45. that would mean that the angle between them is 45. If one's at 0 and one's at 45, then the angle between them is 45. So the magnitude for U is 10, and I'm going to say its angle is 0. So since we're dealing with two angles, I'm going to put a little subscript so that I know whose angle that is. The magnitude for V, it says, is 14. And I'm going to take the angle they give me and say that that is V's angle. So I have a magnitude and a direction for two different vectors. And what they want us to do is add the two vectors together. Now these two vectors are pointing in different directions. One of them is pointing at a 0 direction, which technically is east, and another one is pointing in a 45-degree direction, which is northeast. Those two vectors are pointing in different directions, so we can't just add together 10 and 14. What we have to do is we have to break these two vectors down into components. We can add corresponding components, and then we can turn the resultant components back into a magnitude and direction. So step number 1, change your vectors to components. So each vector is going to have an x component and a y component. So we're going to have a u sub x and we're going to have a u sub y. For the x, we always do cosine, and for the y, we always do sine. So we do magnitude times cosine of the angle, magnitude times sine of the angle. V also needs to be broken down into components. V has a different magnitude and direction, so make sure you use V's magnitude and direction. The x always uses cosine. The y always uses sine. Now, we can figure out what these are. 10 times the cosine of 0 is just 10. 10 times the sine of 0 is 0. 14 times the cosine of 45, you would probably be okay just typing that in your calculator and changing it to a decimal. 45 though is one of our special angles, so if you wanted to use exact values, you could look that up on your unit circle, or hopefully you have it memorized. Cosine of 45 is radical 2 over 2, and if we multiply that by 14, we get 7 radical 2. And sine of 45 is exactly the same, so we get 7 radical 2. So I've got components for both of my vectors. So the resultant vector, when I add these together, we can get the components if we add together the components, corresponding components from each of the individual vectors. So I can get the x component for my answer if I add the x components from u and v. I can get the y component for my answer if I add together the y components for u and v. So this is going to be 10 plus 7 root 2. This is going to be 0 plus 7 root 2. And we might want to go ahead and just change this to a decimal. So give me just a second. I'm going to type this in the calculator. Let's see how many decimals. The magnitude they want rounded to the nearest tenth. Do not round your components to the nearest tenth, We want to keep these numbers as exact as possible for as long as possible because there's more calculations that we need to do. So I would probably keep 2 or 3 decimals right now. Hold on just a second, I gotta grab my calculator. So for 10 plus 7 radical 2, I've got 19.899. And then 0 plus 7 root 2, which is really just 7 root 2, I've got 9.899. So those are the components for the answer. So that was step number 2. Step number 2 was combine corresponding components. We combined our x components, we combined our y components. Now we want to take those components and convert them back to magnitude and direction. So these components, these are the legs of the triangle. These are the legs. So the magnitude is the hypotenuse. So the magnitude of our answer we get just by doing the Pythagorean theorem. So it's the square root of the sum of the squares of the legs. So 19.899 squared plus 9.899 squared, and then we'll square root it. And this is the first answer that MyLabs Plus is asking for, and it says we can round it to the nearest tenth. And I got about 22.2. The next thing that they're going to ask is the angle. And for that formula, since we know our components, which are our 2 legs, which are our opposite and our adjacent sides of our triangle, we're going to do tan. And since we're solving for the angle, we actually do inverse trig. So we're going to do inverse tan of the opposite, which is the y, over the adjacent, which is the x. So we're going to do tan inverse of the y over the x. Now, this answer is going to be in quadrant 1 because this answer is positive and this answer is positive. Both of my components are positive. You can think of those as coordinates on the graph. So anytime you plot a positive x value and a positive y value, you end up in quadrant 1. Your calculator will give you back a quadrant 1 answer for tan inverse. So whatever the calculator says, that's our answer. So we don't have to worry about adjusting the quadrant on this one. So tan inverse, I'm pretty sure it's going to want it as a degree of 9.899 divided by 19.899. I've got about 26.4 degrees. And I'm just doing tenths again. I can't actually see, it says 1 part remaining down at the bottom, and I can't see it unless I enter an answer here, and this is somebody else's homework, so I don't want to start entering answers into their homework. So if they don't give you 2 angles, then you can assume that the first one is 0, and then use that angle for the second one. So this one is very, very similar. They give us the magnitude for two vectors, and they give us the angle between them. The angle between them is 105. So this is question number 5 in homework number 8. It says the magnitude for vectors u and vector v are both 24, and the angle between them is 105. And it wants us to find u plus v, and it's going to want us to answer it in two parts. First, it wants the magnitude for u plus v, and then it's going to want the angle of u plus v. Since it only gave us one angle, we're going to assume the angle for u is 0, and the angle for v is 105. So both their magnitudes are 24, and the theta is 105. First step, we've got to break these down into components. They are pointing in two different directions, so we can't just add their magnitudes together. One of them is pointing at 0 degrees, which is east. The other one is pointing at 105 degrees, which is just slightly west of north. Perfectly north is 90 degrees. And we're just 15 degrees west of that. So very different directions. We're going to have to break u and v down into components. Then we'll be able to add them. And then we'll switch them back to a magnitude and a direction. So we're going to find a u sub x and a u sub y. And a v sub x and a v sub y. Your x formulas always contain a cosine. So one easy way to remember that is back when we learned the unit circle, the x coordinate on your unit circle always represented cosine. And the y formula uses sine, just like the y coordinate on your unit circle represents sine. So, that seems to always happen here in this class. The x always goes with cosine and the y always goes with sine. So the formula is do your magnitude times the trig function and the angle. So for u, we're going to do 24 cosine of 0 and 24 sine of 0. For v, it's got the same magnitude, but the angle is different. So 24 cosine of 105 for the x component, 24 sine of 105 for the y component. Now 105 is not something we have marked on our unit circle, so I'm not even going to waste my time trying to get an exact answer for that. I'm just going to type that in the calculator. 0 is really easy to do. 24 cosine of 0 is just 24. 24 sine of 0 is 0. 24 cosine of 105. Again, make sure your calculator is in degree mode because that angle is given to us in degrees. I've got negative 6.212. The x value is coming out negative because 105 is in the second quadrant. 105 degrees is in the second quadrant. So to get there, I have to move left to get to the second quadrant. Moving left to get to the second quadrant is a negative x value. So that's why the x component is coming out negative. These components are just like coordinates on your graph. They're just like ordered pairs. So 24 sine of 105, I've got 23.182. And now we can add corresponding components. And this will give us components for our answer. So we want to add together the u sub x and the v sub x. So that's 24 plus negative 6.212, which is 17.788. And then for r sub y, we're going to add together u sub y and v sub y, which is 0 and 23.182, which is 23.182. These are components for the answer. Look at the signs of those numbers and take a guess at what quadrant you think the answer is going to be in, based on whether those are positive or negative. Your x is positive. Your y is positive. Where do we plot points that have both a positive x and a positive y? We plot them in quadrant 1. So I'm expecting my direction, I'm expecting my theta to come back as a quadrant 1 angle. All right, so my final answer, if you look back at MyLabs Plus, they want us to answer this question as a magnitude, and then part 2 says a direction. Right now we have components. So the magnitude, remember, is the hypotenuse of this triangle. Right now we have the legs of the triangle. So to get the hypotenuse, we've got to do Pythagorean theorem. 17.788 squared plus 23.182 squared, and then we'll square root it. And let me make sure this is 1 decimal again. Yep, nearest tenth. And I've got about 29.2 for the magnitude. And then for theta, we do tan inverse of the y value over the x value. You always do the y on top because tan is opposite over adjacent. And if you look back at the triangle we drew at the top, that vertical side is opposite of where we drew theta. So we can type this in the calculator, tan inverse of 23.182 divided by 17.788, and the angle is about 52.5 degrees. So very similar to the last one. Angle ended up in a different quadrant, but it doesn't really affect the answer at all. So we have to change our vectors to components. Then we can do the combining that they want us to do. But then we need to turn them back to a magnitude and direction to answer the question. This next one is question number 7. The picture is very misleading, and I suggest you ignore the picture completely. That picture makes this problem look much more difficult than it needs to be. So this is question number 7 on your homework. If you read the problem and you do exactly what we did in the last two, you will be perfectly fine. It says a boat heads 38 degrees, propelled by a force of 700 pounds. I'm going to stop right there. That is a magnitude and a direction. So right now, I've got a magnitude for my boat of 700, and I've got an angle for my boat of 38 degrees. My boat is at an angle of 38 degrees and a magnitude of 700. A wind from 314 degrees exerts a force of 200 pounds on the boat. There is another magnitude and force, magnitude and direction. How large is the resultant force, and in what direction is the boat moving? There is one small trick on this problem. So we also have a wind. Its magnitude is 200. The trick in this problem is that we are not going to use 314 from the angle for the angle, and it's because it says the wind is from 314. We want to know what direction the wind is going to. What direction it's actually moving to. So the boat is moving in a direction of 38 degrees. We want to know what direction the wind is moving in. Not where it's coming from, but what direction it's moving in. So if it's coming from 314, the exact opposite direction on the other side of the graph is where it's going to. So the exact opposite side of the graph would be exactly 180 degrees away. So you're going to want to subtract 180 degrees from 314, and that's what you're going to use for your wind direction. So 314 minus 180 is 134. That's the actual direction that the wind is going in. Not where it's coming from, but the direction it's going in. So I've got two vectors. I've got a magnitude and a direction for each of them. At this point, it's now exactly the same as the last two problems. I need to break them into components. Then I can combine my corresponding components. And then I can take those components for my answer and turn them back into a magnitude and a direction. So we need to find a b sub x and a b sub y. And we need to find a w sub x and a w sub y. Remember, your x formulas use cosine and your y formulas use sine. And it's always magnitude times and then the trig function of your angle. So for b sub x, I'm going to do 700 cosine of 38. And then for y, 700 sine 38. W has a magnitude of 200, so 200 cosine 134, 200 sine 134. And we're just going to type these into the calculator. They want us to round to the nearest integer in our final answer. So I'm going to keep a couple more than that here when I do my work. So I'm going to keep 2 decimals right now. So 700 cosine 38. I've got 551.61. And then if we switch that to sine, I get 430.96. And then for our wind, we've got to do 200 cosine of 134, which comes out negative. So remember in the last problem why that happened. 134 degrees is in quadrant 2. To get to quadrant 2, you've got to use a negative x coordinate. So it makes perfect sense for the x to come out negative when you've got an angle in quadrant 2. This is negative 138.93. And if we do the same thing but with sine for the y, I get 143.87. So I've broken my boat and my wind down into components. Now I can combine corresponding components. I want to add together my boat's x component and my wind's x component to get an x component for my answer. And I want to add together my boat's y component and the wind's y component to get a y component for the answer. So I'm going to be adding together 551.61 and negative 138.93. That'll be the x component for my answer. And I got 412.68, and then same thing for your y's. 430.96 plus 143.87, and I got 574.83. They are both positive, which means we're working with a quadrant 1 angle, so that's good. We don't have to worry about moving anything on our own. They do want this given back as a magnitude and a direction. Magnitude is Pythagorean theorem. And they did say that we can give this answer back to the nearest integer. And I got 708. And then for theta, we do tan inverse of the y over the x. And I got about 54.3 degrees, but make sure you look at the directions under the answer box and see how they want you to round. So again, in this problem, don't even look at that picture. I hate that picture. I wish they didn't even use that. I don't even know why they have that 84 up there. I don't even know where that even comes into this problem whatsoever. This makes no sense to me. I hate this problem. I love this problem, but why they would include that picture makes no sense to me whatsoever. They're so overcomplicating this. You can do this exactly like the other ones. The only trick here they throw in is they're telling you where the wind is coming from instead of telling you the direction that it's blowing to. We always want to know the direction things are moving in. So that's why we had to subtract 180 from the wind. Besides that, we've got magnitude and direction for two things, and we want to add them together. So we break them to components, then we can add the components, turn them back into a magnitude and direction. And we got one more here that I'm going to talk about, and this is number 18. And this one is very different. This one says to sketch, include the unit circle, and calculate the unit vector for a given direction angle. So we know theta is pi over 2. We're going to use the exact same formulas we have been using. It looks like a very different problem, but they are talking about vectors here. A unit vector is a vector that's exactly 1 unit long. So we're talking about something that has a magnitude of 1. The format that they're asking you to write this in is component form. This is one of the ways that you can write a vector in component form. In the first box in front of the I, you would write your x component. In the second box in front of the j, you would write your y component. So component form for a vector, there's two ways you can write it. You could say that vector v is, there's one way that you can write it with these pointy little braces here. You can say v sub x comma v sub y. If you put it in the rounded parentheses, that means it's a point on the graph. If you put it in the pointy braces, that means it's a vector. A vector, like I said earlier, a vector is a directed line segment. It goes from the origin out to that point. So this would be the point v sub x, v sub y. Whoops. But it's not as simple as just plotting the point. We're actually connecting them and drawing a vector. So this vector here, it has a magnitude represented by the length. It also has a direction represented by the angle. So that's one way that we can write a vector with its components. Another way is with the I and the j. So we could say v sub xi plus v sub y j. So what they're asking you to do is write a unit vector. So a unit vector always has a magnitude of 1. So what we know right now on this problem is that we have a magnitude of 1. We know the magnitude for u equals 1. And they also tell us an angle. They say the angle is pi over 2. And be very careful because this is a radian. In all the problems we've done so far, we've used degrees, so you're going to have to change your calculator to radians. So if we know the magnitude and the direction, we can find components. We can find u sub x and u sub y. We've got formulas for that. We've done that 6 times already in the last 3 problems. These formulas are magnitude times either cosine or sine of the angle. U sub x is magnitude times cosine of your angle. U sub y is magnitude times sine of your angle. And we want to simplify those. Cosine of pi over 2 is 0. 1 times 0 is 0. Sine of pi over 2 is 1. 1 times 1 is 1. So we can use that information, magnitude is 1, angle is pi over 2, to find those components. Once we know the components, we just need to take them and stick them into these spots. The v sub x always goes in front of your I, and the v sub y always goes in front of your j. So one of the ways that we can write, x, for this one it's actually called u, one of the ways that we can write u is 0i plus 1j. And we can do that even if it's not a unit vector. They could give us any magnitude and any angle, and we could write the vector out in component form this way. Use your component formulas to figure out what those components are, and then just stick them in front of an I and a j. So that's what they're looking for there in problem number, what was it, 18. So the trick is knowing that a unit vector has a magnitude of 1. If you know that a unit vector has a magnitude of 1, that's half of the information that we need. This is a 1. Because then they tell us that the angle is pi over 2, then we know everything that we need to do components. And then you also need to know that that format right there just uses the components in those boxes. And you're good to go. Sorry. You're good to go. So I hope that helped. If anybody has any more questions, just shoot me an email. I am more than happy to help. I know homework is due tomorrow, so time is running low, and also the semester's running low on time. So just get your questions in, and I will answer. Y'all have a good night.